Okay, let's start. So we're going to pick up from where we are last time. We're still in the middle of 1.1. It's actually a big section. We're reintroducing a lot of things. And so I probably won't even finish today. It'll probably be tomorrow, Tuesday, before we finish 1.1. So let's just go through it. One thing I forgot to tell you yesterday, so it's 1.1 continue. There's another terminology that I might use ever so often. So remember I told you that X was, we can think of that as an input. It's also a domain element. It represents a generic domain element. Another phrase you might see me refer to this as is the independent variable. So I don't want you to be confused when I'm calling something an independent variable. And by the way, you should note, especially in calculus and above, X is, so we call it a domain. It's possible to have other variables. Alright, so X and Y are kind of the generic ones that everyone thinks of X and Y, but really if I wrote something like D equals P of T, I don't expect it to be confused, right? This is your output, T is what I'm calling the input, P is the name of the function, right? It doesn't have to be Y, F, and X, right? I can change the variables to in different contexts. And usually, if I want the input to represent time, I would use T and not X, and I don't want to be confused, right? So X and Y, pretty much anything we're calling, any name of any variable, it doesn't have to be that. It can be anything, okay? And so Y was what we introduced last time as, that's the I don't just want to say output, I want to say the corresponding output, right? So you plug in an X into a function, it does some kind of rule, and it spits out a Y. And it can only spit out one Y. That's what makes it a function, right? If there are multiple things that it could spit out, it's no longer a function, it's another kind of relation. So this is the corresponding output. It's also called a range element because it's in the range of the function, and it's called a dependent variable. Right, so that its value will depend on what the value I plugged in, right? So the Y value will be different, can be different if I plug in a different X value. So the input is called the independent variable. That's the thing that the function has no control over. But once you put it in, the answer it gets is dependent on what you put in before. So Y is sometimes called the dependent variable. But just think of it in general as output elements are dependent variables, input elements are independent variables. They don't have to be called X and Y. In a lot of cases they will be, in most cases probably, but don't be married to the names of things, is the moral of the story. So let's see where we were last time. So yeah, we did that example of my hot dog stand. We're going to move on now to evaluating functions. Right, did you guys go over that example with the hot dog stand? Do you guys think you understood everything? By the way, just a question. No one, you probably won't know the answer, but can you guess if I were to use calculus in that problem, where the calculus would have happened? Yeah?
You can use first derivative to find the vertex.
To find the vertex, right? So remember all that crap we did in solving that problem? Calculus would have shown up in one part. That part where I did the minus b over 2a. That's all calculus would have helped you with. You would have noticed literally everything else I did. I had to sketch a graph. I had to know what was how to find the equation of a straight line. I had to know how that I was looking at a parabola. I had to know all these things. And calculus was just one little part of it. Most of what we will be doing is algebra, and that's what students don't realize. And that's why going over that first quiz is going to be very important. because the majority of what you will be doing is algebra. Calculus is always going to be a very small part of it. The idea is that formula to find the vertex, like that x equals minus b over 2a, it turns out that that formula only works for quadratics. For more general functions, there is no formula, and that's why the calculus is useful, right? You can find the highest point or the lowest point and a lot of other things without knowing a general formula. And so that's why the calculus is going to be important. But really, everything else you're doing around it, it's algebra. You just have to know your algebra and know when to do what things. Okay. So we're going to move on to the next thing, which is evaluating functions. What do you want to think about evaluative functions? Basically, figuring out the output for some input. And we do this by plugging in. So, example. Let's say I gave you a function f of x equals, let's go back to this one. We spoke about that last time. So this is just a rule. I give it an input, and what it's going to do, it's going to square that input and then add 1 to it and then tell me the number. That's going to be the output. And I want you to find these values. 1, 2, 5, f. So you're given this function, and we want to evaluate the function. So when we say f of 1, this means we want to evaluate the function at 1. F of 2 means we want to evaluate the function at 2. And evaluate it at 5, evaluate it at a, evaluate it at minus a, evaluate it at a squared, evaluate it at a plus h. Okay. What is f of 1? 2. Okay. Give me the steps. What do you do? Yeah? Right. The 1 goes in the position of the x, right? Whatever's in the parentheses here, you put it in the position of the x's. So 1 squared is 1, 1 plus 1 is 2. So in other words, if I evaluate this function at 1, the output is 2. In this case, 1 would be the input element, 2 is the output element. What about 2? Same idea. 2 goes in the position of x. 2 squared is 4. 4 plus 1 is 5. What about 5? Same idea. Okay, what about a? What is f of a? Yeah?
A squared plus 1.
A squared plus 1. And you leave it like that. You don't, that's the answer. Okay? You just replace the x variable with whatever is inside the parentheses. What is minus a? Yep?
A squared plus 1.
Right. So it's minus a squared plus 1. And we know that if we square a negative, we raise a negative number to an even power, it becomes positive. So this is also just a squared plus 1. It's exactly the same as there. So on the quiz, there were times when I asked you things about what's the difference between like minus, I don't remember what number I used, maybe it's 3. Minus 3 squared versus minus 3 squared. And you guys knew the difference to that? Right, so this one was actually negative, so it would be a negative 9, for example. This one is actually a positive 9, right? And you need to know the difference between the two. Okay, so, and that was because it's an even power. Okay, what about this one?
20 to the 4th plus 1.
Replace it with the x, square it, plus 1. And now there's a law of exponents that says when you have something to a power, you raise it to another power, you multiply the powers. So that's 2 times 2. That's going to be 4. And we'll actually go over the laws of exponents again. What about a plus h?
A squared plus 2AH plus H squared plus 1.
Okay, you're skipping ahead too far. Come on, slow down. A plus h. What did you do? What was your first step?
So like substitute the x with A plus H.
So for the time being, especially if it's been a while since you've have done math, you really want to write down every step and know what you're doing. So the first step you're going to want to do is take whatever's in parentheses here and replace the x with it. And so now this is something we spoke about on the first day. You have to FOIL it out, or you know that formula. So this is going to be a squared plus 2ah plus h squared plus 1. This is cool. I don't know what happened. Probably slept weird on it. This was an example, but I just want to make sure that we're all on the same page. Let's say I said f of x was x squared plus 3x plus 1. What is f of a minus h?
So it's A minus H squared plus 3 times A minus X minus H plus 1.
There's a very common mistake that students would make with things like these that I want to mention. Is that they think that when they see an operation happening inside the parentheses here, they just do it to the function on the outside. So for example, if I had f of x equals like this guy x plus 3x plus 1, and I ask them, oh, what is f of x plus h? What they do is they write this down. And they add an h at the end. That is incorrect, right? That's not right. So I want to make sure you guys get that point across. That's not how you don't just do the operation that's inside here. When you have this function notation, what it means is whatever's inside these parentheses, you're going to replace it with the position of the independent variable. And this we can actually do out, so that's a squared minus 2ah plus h squared plus 3a minus 3h plus 1. Actually, I should probably write down what I just said just to make sure. So the idea, so if I say f of x is equal to x squared plus 3x plus 1, you kind of think of this thing as a placeholder for, you're going to put something here, you're going to square it, you're going to put something here, multiply it by 3, and then you're going to add 1. And it doesn't matter what I put in here, you put the same thing there, right? If I put 16 here, put 16 here, put 16 here, put 17 here, put 17 here, put 17 here. What is f of smiley face? Smiley face squared, put it in parentheses. This is one of the cases where you're going to want to use parentheses because things have to distribute and all that. Plus 3 times smiley face plus 1. Another thing that happens to students a lot is they see something and it looks scary and it freaks them out. You shouldn't be scared. Really understand what you're doing. It doesn't matter how scary the thing looks that I put here. Put it in this position, put it in that position. And it's no more complicated than that. Okay, I could do something like the square root of x cubed plus radical 2. And you're like, oh my god, I don't know, how do I square root? It doesn't matter. You just take that, you put it here, you put it here. Okay, that's what I want to get across. Okay? So a lot of times things will look really messy and look scary because the numbers just aren't nice, but don't let that fool you. How functions work, if I want to evaluate a function, whatever is in parentheses, I just take that and I copy it every instance where the x happened. Right? And it doesn't matter how it looks, that's just how they work. That's how we evaluate functions. And some more examples of that. But do we all get the idea? I think I'll just skip the next two examples and move on to something important. It's called the difference quotient. So this is an example of a very important composite function, which we'll talk about composite functions later as well. There's something called the difference quotient. So for a function f of x, its difference quotient is the following, right? So it's this expression, f of x plus h minus f of x all over h. This is called the difference quotient. Another form that you might see the difference quotient in is something like f of b minus f of a over b minus a. But we will use this one more commonly. This one it's kind of what we use. Not sure why, but maybe historically, traditionally, we kind of use this form when we want to do something like find the average rate of change. We'll talk about that later, but that's kind of what we use. So most of the time, if I say, "Hey, what is the difference quotient of this function?" I'm talking about this form. It's a very important formula. I suggest you memorize it. It's something that you've probably seen before. We'll talk about where it comes from and why it's such an important thing and why people harass you about it, even though you probably don't even know what it's about. We will actually, in this class, talk about where this expression comes from. But for now, I just want you to be aware that there is this expression out there. It's very important for us to be able to calculate it. One thing I want to stress here, if asked to evaluate and simplify the difference quotient, the goal is to cancel the h. Okay. So you would have seen a difference quotient. Actually put a couple of problems about difference quotients on the quiz, and I said, oh, simplify this, right? It is not considered simplify until you cancel this h. And when I explain to you what this guy is and why it's important, you'll realize why that's important. It's because at some point in certain contexts, we're going to want to be able to plug in h equals 0, and we cannot actually divide by 0. And so you simplify it to cancel that so that you can plug in h equals 0. Right? And we'll talk about that later. Don't worry about it for now. Just understand this is an expression. It's a very important expression, and we'll talk about it more. But if you're simplifying this expression, you keep going until you cancel that h that's in the denominator. So let's do some examples of this stuff. So suppose my f of x is 2x plus 3. That's one function, that name called f. And my g of x is 2 plus x minus x squared. Find the following. So it should be find and simplify. Simplify that expression. Then write in a third function here. Called k. Probably finish here. Okay, what are we doing this week? Anyone, come on, don't be shy. What are you doing? Does anyone know what to do? Yeah.
Maybe start by putting the b into the formula for 2x plus 3.
Okay.
So it would be 2b plus 3. And minus 2a plus 3. But that's as far as I
Okay. What else? Parentheses, super important. What else? All over. Okay, so let's talk about this for a little bit. So again, here's an expression. It might look scary to you. I don't know what to do. You take it piece by piece. Just focus on one thing at a time. F of b. I'm going to write f of b in this position. What is f of b? Well, I know what f of x is. F of b just means I put a b in the position of the x. Right? That's what we spoke about last time. So I literally just recopy that formula and write b where the x was. Right? What's the next thing? Minus sign, put a minus sign. Then I'm going to put f of a. So because I know f of x, f of a is just this guy with a written instead of x. So I write that here. However, because there's a minus sign, the distributive property is going to apply. I need the parentheses. Then what else is there? Big down, big line, b minus a, b minus a. Take it piece by piece. Okay? So you will have to know how to evaluate functions in order to put everything together. But once you do know how to do that, just go little by little. Do this part, do that part, do that part, and use your parentheses appropriately. Okay, let's simplify this. What can we do here? Yeah.
You can subtract the 3's. Cancel the 3's out.
Let's just take it one step at a time and expand things. Yeah, so we can subtract the 3's.
And then you take out a 2. from the top, from the numerator, and it's b minus
So
a.
now there's a 2 is a common term. I can factor that out. And what would I have?
You have b minus a, and then
B
over
minus
b
a
minus a.
divided by b minus a.
Cancel those out. Your
And
answer's 2.
because there's a multiplication separating these terms, I can now cancel. So this whole thing just simplifies to 2. Any questions?
Can you go back and just do that real quick? I missed that. Can you do it again? From
Let's-
the after you got the 3's gone.
Okay, so hold on, let's start from the beginning. Okay, so you see this expression, oh my god, don't freak out. Just know what it means to find f of b, f of a, you just take each piece one at a time. Okay, so you go to here. What is f of b? Just replace b everywhere. So you get 2b plus 3. Then you have to put in f of a. Well, that's 2a plus 3. You're in that position. Subtract them, you need the parentheses here, super important. It's often forgotten. All over b minus a. Okay, so we do this guy. Okay, so what we did first here is expand the parentheses, so the negative sign comes from this next guy. So now we have a plus 3 and a minus 3, so they just kill it. Okay. And what we have, you will notice that we have 2b minus 2a over b minus a. But we need to simplify, we need to cancel the denominator. Okay, and so you really want to cancel, but you can't cancel because there are sums, so you want to really factor things. And one thing that we look at when we're factoring is we try to pull out common terms first. There's a 2 in each individual, and so I just factor that out. And then we end up.
Okay.
So you get it?
Thank you.
And so now we can cancel. It's probably confusing because I left the 3's there, but if you were writing it out strictly speaking, this would have been the next line. And then that. Any other questions? So it's a lot of algebra, but it's going to be very important for us to be able to simplify expressions like this. Because it's going to be important for calculus. It's not just an algebra exercise. This is going to be a part of the calculus that's going to happen. But there's an algebra component to it, so that we need to be sure. Okay, what about this one? Someone take a shot at it. Yeah?
Start by getting g of x, and then for the x's plugging in x plus h.
Okay. And so what would we have?
You have 2 plus x plus h minus x plus h squared. And then subtract that from the original g of x, which is just 2 plus x minus x squared.
Parentheses. 2 plus x minus x squared. And then put it all over h. Now, especially if the thing you're plugging in has several terms, like it has an x plus an h, I would literally always put that in parentheses just to be safe. You really want to use your parentheses to guide you so you don't make a mistake. Because you forget them. Right, so if you forget it like here, for example, you might think of that as, oh, only the h is squared. But it's not only the h that is squared. It's the sum of these things that are squared. Okay, so now that we have that, what's the next step?
Foil out x plus h.
Yeah, multiply out. I don't know. Let's give ourselves some. So we start just recopying everything, but while expanding. So 2, I can just remove the parentheses here. Here, though, I need to foil this out. What is that?
X squared plus 2 x plus h squared.
Then?
And you just minus the g of x.
Minus
2.
x plus x squared.
Is that okay? Something's wrong. Does anyone see what's wrong? Yeah?
There's some parentheses on the last one.
Very important. It won't work out otherwise. what I meant about parentheses. You need to keep them, right? We're subtracting something, put that thing in parentheses, because that negative sign is going to have to be distributed, right? So you need to always remember, after a negative sign, when you're subtracting something, open parentheses. Then you put a minus sign, open a parenthesis. Just make it automatic. Okay? When you get more experience, you will know when you can leave them off and when you can't. But for now, just always put parentheses after a minus sign. Better safe than sorry. Okay? Because now what that means is all the signs here are going to change. Okay, now.
Cancel out terms. That like
Okay, now sir, some of these terms will kill each other, right? So I have a plus 2 and a minus 2, so that's gone. I have a plus x and a minus x, that's gone.
the x squared.
X squared.
I have a minus x squared and a plus x squared, that's gone. That's it?
Yeah.
So now, let's just, because there's a lot of strikeouts there, let's just rewrite it just to see what happens after the dust settles. So we're left over with an h minus 2xh minus h squared. That's it, right?
Divide by h.
Yeah.
All over h. Now remember what I said, the goal is to cancel that h in the denominator, so we're not done. What else? What do we do now?
Take out an h.
Just cancel that, right?
No.
No, cannot do that. Okay. You might have had the urge. Do not go with that urge. You cannot cancel across sums, right? There's a minus sign and a minus sign here, you can't cancel. So what do we do?
Take out h.
Yeah.
H is a common term in the top, so we're going to factor that h out. What do we have left?
1
1.
minus 2x minus h.
There's a multiplication here, which means I can cancel those. And that's the answer. Any questions? The other one was K. So K of A plus H minus K of A all over H was the next expression we wanted to do. Our K, remember our K was just x over x plus 2x. Now what? Start with K of A plus H. What would that look like?
A plus h over
Divided by A plus H plus 2. So I'm just, I see an X here, write A plus H. I see an X here, write A plus H. Minus K of A. Whenever I see an X, I'm just going to write an A instead.
Over h.
All over H. Right? Now there's only one thing here. You can put parentheses if you want. In fact, if you're not used to mathematics that much, it's been a while, or you just feel kind of shaky or nervous, put the parentheses. It's not going to hurt you. But you, strictly speaking, you don't have to. So now remember, our goal is to cancel that H in the denominator. How do we do that? How do we simplify something like this? What's the quickest way to simplify something like this? Do you guys remember what an expression like this is called? A fraction with fractions in it? It's called a complex fraction. That's what it's called, a fraction that has fractions in it, we call it a complex fraction. Okay, so How do we simplify complex fractions? Quickest way.
Reciprocal.
Reciprocal? Sure, if you're dividing one fraction by another, how you do it is you multiply by the reciprocal of the denominator. But there's an easier way. When you have fractions inside of fractions, there's a quicker way to do it. The goal is to multiply by a certain expression. It's to multiply by... No. You're going to want to multiply by something that you can cancel the denominators, and it ends up being the LCD.
Oh.
So you multiply and divide by the LCD. That's the quickest way to simplify a complex fraction. We know what the LCD here is. So all the fractions, the denominators are this, this, and 1. What's the LCD of those expressions? A plus h plus 2 times a plus 2. Right? They have no common factors, so the LCD is just going to be their product. This will immediately turn the complex fraction into a simple fraction. As opposed to you have to combine these and then you have to flip and multiply. You can do things in one step instead of 2 steps. You know, you lessen your chances of having to make a mistake because you're not doing as much. So the trick here was to probably want to put this in color chalk right now. Multiply and divide by LCD. Least common denominator. Right? So that's when you have a complex fraction. Now what you're going to do is you're going to do the distributive law. So you're going to take the top and you're going to multiply each term in the top. So if I take this expression and multiply that expression, what's going to happen? See, these guys will cancel.
Yeah.
And then I'd be left over with this times that. Minus, if I multiply this by that, the a plus 2's will cancel, and I'd be left with this times that. Over, I'll just leave this, and this is just going to be h times a plus h plus 2. So now it's not a complex fraction. But we're not out of the woods yet. That h is still alive. We need to cancel that h. There's a sum here, and h is not a common term, so I need to get a common term, so I'm thinking I'm just going to expand all these things. I'd expand something like that. Something like that was on the quiz, I believe. So expand parentheses, you take each individual in one set of parentheses and multiply every individual in the other. So I'm going to take this a, multiply that, multiply that. So that's going to be a squared plus 2a. Then I'm going to take the h, multiply that, multiply that. AH plus 2h. This one, distributive law, again, multiply everybody. And notice that this a here has a negative sign, so all the signs are going to change. So that's going to be minus a squared, minus AH, minus 2a, all over by the way, when you want to simplify a fraction, never expand the denominator. It's usually going to be a waste of time. So I'm not going to FOIL this out. You don't want to do that. The denominator, you always keep it in factored form. The numerator, you might have to FOIL out, and that's fine. Okay, so now what happens? The a squares die, 2a's die, the AH die. So I end up with 2H divided by H times A plus H plus 2 times A plus 2. There are only multiplications, both in the denominator and the numerator, which means I can do cancellations. And we kill that H. So now we end up with 2 divided by A plus H plus 2 times A plus 2. And that's it. Any questions? Make sure you go over this. It's going to be very important for you to be able to do things like this quickly with all sorts of functions, complex fractions, not complex fractions. And we'll stop there. I'll see you guys on Tuesday, and we'll have a quiz on what we've been doing so far. So everything we did on Wednesday and today will be on the quiz on Tuesday. So write up the simplifying difference quotients.